So I want to talk a little bit about standard deviation. All right, so standard deviation is a really useful statistic. As it says here, it is the average amount each data point varies from the average. All right, so based off this definition, we can tell, all right, if I have a large standard deviation relative to other standard deviations for the same kind of data, there's a lot of variation, right? The data points can be close to or maybe really far from our average. But if I have a small standard deviation, then the data points are all going to be a little closer in to towards the average. You know, they might just be a little bit above it, a little bit below it. Okay. So the thing about standard deviation is that if you have a normal distribution, and it's important you have a normal distribution. If you don't have a normal distribution of data, standard deviation doesn't help you very much as far as predictive power. But if you do have a normal distribution, something basically like this, you want like a really nice bell curve, then what that means is if you start with the mean, okay, and for this data right here, we calculated the mean as 28.350, so that would be a little to the right of the middle of this bar. If I add one standard deviation, which I found was 4.711, all right, so that's going to take us up to 33 more or less. And if I subtract one standard deviation, all right, so that's going to take us down to 23.639. All right, so a little over here. What I should see is 68% of my data captured in that area. So roughly from 23.6 all the way up to 33.06. All right, looking at this chart, yeah, that looks about right, because 68% is a little more than 2/3 of your data, right? So if I go 2 standard deviations away from the mean, all right, and again, my mean, I'm going to bold this so it's easier to tell, is 28.350. So now I'm looking at a range from 18.927 all the way up to 37.773. That is off the chart down here, and almost off the chart down here. 95% of my data should fall in that range. Okay? And clearly that's going to be true for this thing, right? Because basically everything from the bottom all the way up to somewhere in the middle of this bar of our data is kind of in that range. All right? Finally, if you go 3 standard deviations out, all right, so you start with your mean, which was 28.35, and go up 3, so that's 42.484, and you subtract 3 standard deviations from the mean, so all the way down to 14.216, then 99.7% of your data should be in that range. All right, and with our data, all of our data is in there, so just about 100%. All right, that is how you use standard deviation. This is a useful reminder. They call it the 68, 95, 99.7 rule. All right, and for question 1E, it's asking how would you predict where 95% of all your marshmallows launched would fall. All right, so taking standard deviation, we can predict that kind of data just by starting with the mean and adding and subtracting 2 standard deviations away from it. That would be the range where 95% of my marshmallows would fall. So for me, it's going to be from here all the way to there.